Right, so we're going to go through the parts of the compass clinometer used for, geologizing. So the first part that's important is the hinge lid. It has many useful uses in geology. It's got should have a line down the middle of it, so that's useful for sighting to figure out the direction from one place to another. Figures out where you are. It's also got a mirror, which is useful for checking your makeup and whatnot, because there's no point being in the field if you're not fabulous.
Alex, what Alex actually means is that when you are doing some sighting, you will tilt the compass to an angle where you can line up your red part of your magnetic
Needle,
with the red part of this, and then that will
yeah,
help you to do your actual sighting and figure out where you are on the map, not make sure that your mascara is not running because it's raining. Anyway,
that is true. It's also useful for checking yourself for ticks as well.
in those hard to reach areas.
Yeah. Anyway, so that's the lid. It's also quite useful when taking dips and strikes for putting on the rock. So yeah, in those kind of ways as well. Right, the next part is the ring, which kind of rotates around, which allows us to measure angles of direction. And you can read it off either end, but you need to think about which end you're reading off when you're, taking measurements. So the next part of the compass is, I guess, the most important bit, which is the needle, which is the magnetic bit, which points towards magnetic north. So the red end with the glow-in-the-dark little splodgy thing on points towards magnetic north. So before you start using your compass, you should make sure that flows.
Well,
rotates. It rotates
and floats in the liquid nicely.
So it's not stuck in one direction. Also, you want to ideally make sure that there's not a bubble in your compass, because they're usually full with some kind of fluid, and you want that fluid to be free of bubbliness. The next part of the compass are the lines which you use to line up the compass with either magnetic north or grid north on the map. So you can see on this compass we've got red lines, which are thin. Okay, and they are for aligning the compass with north-south on your map. Mm-hmm. And then we also have a larger set of red lines, which sometimes might have an arrow on one end. It's usually got a red end and a black end. And those are for lining up with the compass needle. So at the moment, these are both parallel with each other. So in this case, the magnetic north and grid north are both in the same direction. But in reality, there's usually a slight difference between grid north and magnetic north. So if you turn the compass over to the other side, there's a tiny little screw hole, okay? And most compasses also come with a tiny little screwdriver, okay? Which is not for kind of holding next to the needle and using its metalness to deviate the needle. It fits in this little screw hole, and you'll notice as we turn it, the difference between the big red arrow and the grid line lines on the compass can be changed. Have you really broken it already?
No, I wasn't to do this very well.
So you'll see that there's a set of red numbers now, and it says from west declination to east declination. And if you look at your map, if you've got an Ordnance Survey map, it'll say on the map what the local difference between, or local declination between magnetic and grid north is. So that's the thing you should check before you go into the field.
In Scotland, it's like slightly off. It's about 2 degrees, but I can't remember if that's east or west. So that is definitely something you need to check.
Yeah. So if in doubt, leave it at 0, and then
work it out later.
You can work it out later. All your data will be off. But anyway, so it's usually small in the UK, and you wouldn't want to work anywhere else than the UK anyway, really, would you? Because it's super awesome.
Well, some people would think that.
Yeah. So the next part of a compass kilometre. So this is kind of a unique feature of compasses that are used in geology, is that they have a clinometer function, which allows you to measure angles from the horizontal. So it's kind of a dangleometer. So it's very important when you use this tool that you set the compass ring to east-west or west-east, so that those red numbers are now lined up best vertically with the compass. And you hold your compass vertically on the surface that you're trying to measure the angle of. Let's use the geology game, yeah.
Let's measure the angle from the corner of the geology game to the table.
Yeah, yeah. I guess that's a terrible example, but
yeah, terrible example. But it's the best example we have with flat surfaces.
Yeah, so we could measure, and then you can see now that we've got this black. Oh, we're going to focus. Yeah, black arrow now that is pointing directly downwards, and we can read off that it's now the angle of dangle is 28 degrees. So a thing to check is that your angle of dangleometer is also free moving and is not stuck, and also is not missing from the compass. That would be a good thing to have not missing.
We have had someone have theirs like randomly fall off, which renders the compass useless. So because it also then would interfere with the needle. But yeah, if you have your compass and you move it backwards and forwards at steep angles, you should see that the dangly bit should always be vertical.
Yes.
That is the important thing.
Dangle is an important measurement to make.
Yes.
Yes. So if you are going into the field and expecting to do some geology, and you have a compass that does not have this feature of the clinometer, the angle measurer, then it is useless. Leave it at home. Bring a better compass.
Don't bring it.
You can make your own with a stick and a string. But anyway,
Don't give them ideas, Alex.
You have to do maths to do that. But anyway, right. So that's how. That's the parts, not how. That's the parts of a compass that you should, be familiar with. They also have a string. This is for attaching it to your neck, so you don't lose it. And also, the string is exactly 50 centimeters long, so you can use it to measure things that are exactly 50 centimeters long. That won't work in the anyway. Right. So that's the end of the introduction to the compass fiasco. Right.